Advancing RAN management with dApps Real-Time RIC from Fujitsu Research India Private Limited, and Nishant obviously has a strong history of work in this area as a product line manager in Fujitsu Research, about 17 years of expertise. 5G or on RIC, Sean and Mac, slicing all the typical features of 5G networks he has worked with. He also worked with many other companies like Ericsson, Nokia, Huawei, Motorola, Cisco, Intel, Tejas, just to name a few. And also other operators such as AT&T, Sprint, Vodafone, he had collaborated with them. You have also launched successfully 20 innovative products. And so you have both product experience and deployment experience as well. So now you also have standards experience as well. So I'd like to hear from you what ideas you have, what you think we can take it forward as potential standardization or collaboration with other parts. With that, I will hand it over to you, Nishant.
Yeah, thank you.
All right, sure. So Nishant, you have been seeing what's going on. Now, you have to tell us what kind of thoughts you have, how is there any potential power that can be generated. So please go ahead with your presentation.
Yeah, so hello everyone. My name is Nishant Tiwari. I'm a product line manager from Fujitsu. Thank you also, sir, for giving me the opportunity to talk about advancing RAN management with dApp, micro app, and real-time RIC.
Next slide. Just have to tell me next.
Yeah. So next slide.
You should see the next slide now. Yeah.
Yeah. So as a Fujitsu, we are building a new possibility by connecting people, technology, and idea. And as a Fujitsu, we are serving the people in computing, network, AI, data and security, converging, and technology. Next slide. So here I'm going to talk about what is the 5G use case status. And then I'm going to talk about the app journey RICs. So I'm going to talk about all the three RICs: non-real-time RIC, near real-time RIC, and the real-time RIC with the time scales, RF and XF, micro apps, dApps. And then later on, I'm going to talk about real world case applications. Next slide. Yeah. So use case study, if we can see the market. So maximum use case is with the NSA, where we have a mobile broadband use cases is only we are seeing in the actual deployed network, and then fixed wireless access use cases, and then ultra low latency type of communication, and then machine type of communication. And if we'll talk about in technology deployment, so maximum massive MIMO is deployed for the 5G network, and after that a non-massive MIMO, and then only few pockets we have a millimeter wave deployment has happened. And percentage of adaptation, so maximum mobile broadband related use case is adopted in a real scenario, real field, and then fixed wireless access IoT device and private 5G network is still not as much what 4G have. Next slide. So here I'm going to talk about the app journey. So how this different application, DSON, CSON, hybrid, RApp, XApp, centralized platform, and distributed platform happen. So initially, when we have the 3G network, we don't have any application, only protocol stack is there, and all the definitions of the NR, PCI conflict and confusion. If anything is happening.
If you're, can you mute yourself if you're not speaking? There was some background noise. All right, go ahead, Nishant.
Yeah. Yeah.
Please go
So
ahead, Nishant. And there was
so
some background noise.
yeah. So yeah. So in initial stage, when we don't have the DSON or CSON application, we are doing all those functionality manually. We are defining the neighbor relation, PCI conflict and confusion. If in network PCI's collision or confusion is happening, we are just checking the network and defining. And then later on, when we have a multiple use cases related to the ANR or PCI conflict and confusion, and when traffic is high at the time of event, we are doing all those manually. But after that, we start putting all those cases as a baseband unit on top of the MAC layer or a DU. In initial stage, it's not the DU. We have a compact solution, and in that compact solution top of BB unit, we are putting this application, and we are calling as the distributed SON. And then later on, when we have a multi-vendor scenario, different vendor is there, and we have to define the ANR or PCI conflict and confusion, then centralized sound community picture. And the scenario, when we have the both the things, few things is done by DSON and few things is done by a CSON. Let's take the example. Suppose if NR definition is based on the event, then we are doing by JSON. But if we want to define the NR based on the distance, then we are doing by a CSON application. So both type of application, when they are working together, then we are calling as a hybrid SON, and we are defining it through the SON. And when open RAN architecture come, then we are start putting all those DSON and CSON application there SDK as a RF and a non-real-time RIC platform. So we have a different platform, non-real-time RIC platform, near real-time RIC platform. So again, so non-real-time RIC platform is based on if any application need to take a decision after 1 second or 15 second, 5 second, or 5 minutes, 10 minutes, then those application is the part of the RF application, and the application which take time sensitive applications like traffic steering use cases, scheduling related applications, interference related application, beamforming related application. Those applications where we need to take a decision in the less than 1 second. At that time, for those type of application, we are putting as a accept application. And then we have a different platform, also centralized and distributed platform. Next slide. So here you can see the different RIC and time scale. So non-real-time RIC, we have RF applications, and then near real-time RIC, we have the XF application. And then time scales also, if application need to take a decision after 1 second, then it will be the part of the RF application in a control loop. And the application which require time latency within need to take a decision within 1 second, then it will be the part of near real-time RIC. So near real-time RIC and non-real-time RIC is the platform, and on that platform, we are onboarding different RF and XF application. Any application which is require a latency or a decision making less than 10 millisecond, real-time control. So again, this is the other question, right? So real-time control platform will be the part of a near real-time RIC or a near real-time RIC. So that again standardization need to take place. That is again under discussion. So the application which is the part of the DU, we are calling as a micro app, or we calling as a distributed app. So distributed app will be the part of the CU, DU, means both the CUCP or CUP or a DU. And later on 3, 4, 5 years, I think one new application will come. That is the top of the RU. We may call as a nano app. Can you move to next slide?
You are on the next slide.
Yeah. So here I'm going to talk about one RF application, that is a canary application. So that is a Fujitsu inbuilt application. And why I'm going to talk about this application? Because this application, few interfaces is a proprietary interface and few interfaces is a standardized interface. Where we have the proprietary interface, we have the opportunity to develop that interface and standardized it. So what this application does, suppose we are deploying a software in a VCU or in a virtual environment, VCU and video. In that case, if uncontrolled software release is highly virtualized, disaggregated, and complex RAN environment disturb the new network operation, impact performance, and compromise service quality and experience for a B2B and B2C customer. What's problem? It's include CUD performance degrade if we have uncontrolled software release, loss of interoperability. If we are deploying the software at the DU in and we don't know the version of the CU, it is compatible with the DU or it is compatible with the RU, then again there is a loss of interoperability and loss of end user experience. It may happen call drop or handover failure. Yeah, multiple things happen, and that is can impact the end user. Impact to optimize resource allocation for slice. Yeah, so again, if DU is particular DU is supporting slice user and we have upgraded it and we have not particular type of patch, that again that is going to impact the end user experience. And security is one other vulnerability things also that is impacting whole telecom industry. Next slide. Yeah. So we are calling that application as a canary release is a strategic approach to maintain a new feature deployed in a disaggregated and distributed radio access network. MNO use it to identify potential problem in a subnet of a VRAN function prior to wholesale release. So by selecting deploying a canary release to a small group of a virtual network function or application, operation can find and fix problem before they are applied to the whole network. Can please go to next slide? Yeah, so how, what is the Fujitsu solution? So this is the complex environment need automated deployment. So we are calling this product Virtura SMO Canary R provides the control over details and criteria for promoting the release, measure the KPI and engagement impact of the release, user configuration, performance, and stability threshold to trigger an automated rollback. Can you go to next slide? Yeah, so again, I'm not going to explain how it is going to benefit. Can you go to next slide? So I'm going to tell how this RF application work. Suppose you have a 5G G node B CU and DU, which is running in the version .21 in a production environment. And we want to deploy the VCU and video software. So set off only limited 10% of, just I'm want to give the example, only 10% of the VCU and video, we are going to deploy a new software, or we are going to upgrade the VCU and or a video software. In that condition, when we are going to deploy, we are going to monitor both cloud infrastructure as well as a network infrastructure. If we are finding the problem in a means pod is not running, or there is a problem in upgraded software, and after upgrading, we are checking both network monitoring as well as the stability assessment from the RAN point of view as well as a cloud point of view. So if any call related or handover related or any KPI impact is happen, then we are going to roll back that particular software and we are going to put the earlier software. And after, can you please go to the next slide? Yeah, so again, after the fixing the software, we are going to give a new version of the software, 22.01, and that is a production ready software, and that can software can be applied in whole network. So this is a one example of a RF application. So how this application is going to work in ORAN, non-real-time RIC platform. Can you go to the next slide so that I can explain? Yeah, next slide. Yeah. So this is the Canary RF, which is running top of a non-real-time RIC platform. And Canary RF having a interface for both cloud infrastructure as well as a network infrastructure. So this application is communicating with the network infrastructure through the O1 interface and the cloud infrastructure through the O2 interface. And uh, when we are going to deploy the VCU and video software, we are going to deploy through the O2 interface. But O2, this plugin from a non-real-time rig to the O2 interface is not standardized yet. So this is the area where standardization is required so that it's easy for any RF providers can easily interact with the cloud infrastructure so that means all this RF application can deploy, undeploy, or monitor cloud related activity. And through the own interface, same application can monitor the network related monitoring, health check, fault related things through the own interface. So this is the area where I can recommend. ORAN Alliance is working on it, but here also, if some standardization can happen, because again, this is the area where industry is not finding any standardization. And one other thing, plugin this application to the transport layer, that is also not happen. So this is the area where my recommendation is for the standardization. Can you go to the next slide? So here I'm also going to talk about the energy saving application, and which energy saving application is the part of the RF application, and which energy saving application is the part of the XF application. So if I'm going to talk about the RF application, carrier cell switch on and switch off is the part of the RF application. RF channel reconfiguration on and off is the part of the RF application. And O cloud resource energy saving is the part of the RF application. But again, for that standardization is required, because all those initial two use cases like carrier, cell switch off and switch on, RF channel reconfiguration, that is the application which is related to the network. But the application which is a part of the O cloud resource energy saving mode, it's not a part of the network application. It's a part of the cloud infrastructure. So for that, we require a standardization so that this application from the same non-real-time RIC platform can interact with a vCDU and video devices. Can you go, please, next slide? And one other thing here, so accept application. Yeah, same slide. So can you go to back slide? Next slide.
Tell me which one,
Yes. So
energy saving or
yeah.
am I on the right slide or I should go to the next one?
Yes.
Is it
I'm
the right
not able to
slide?
hear. Yeah, it is the right slide. Yes, yes. Thank you. So yeah, so again, the XUP application, because advanced sleep mode require a latency or a time scale of less than 1 second. So for the energy saving application, few use cases which is related to the RF application, and same energy saving application which is require a latency or time scale less than 1 second. That's the part of the XUP application. Can you go to the next slide, please? So here I'm going to talk about so what is the D app, micro app, and then DSON and CSON. So again, when we have the traditional RAN, we are putting the application like interference management, carrier aggregations, applications, and then the, yeah, traffic steering use case between 3G to 4G or between the 4G to 4G, right? So that is the part of a traditional RAN application, and then we are calling as the DSON application, distributed SON application. Now all those application, when we are going to put in open RAN environment, we are calling as a dApp application. But dApp application or micro app application is not only limited to a network related application. dApp or micro app application is also going to consider the application like a cloud gaming application or AR VR related application where we require a very minimum latency to run those type of application. So here I want to show you that dApp or micro app can be the part of the CU or it will be the part of the DU, depend upon the latency or time scale, what is required for an end user to satisfy, uh, and what exact use case we are going to solve from that particular application. So from the dApp application, few application like if you're uh, talk about beamforming application or interference related application, scheduling applications. So that is a network related application that is going, this type of application is going to help the network. But the application which is like cloud gaming related application or critical services related application, video content related application, that type of application can provide a new revenue stream to the operators. Can you go to the next slide? So here I want to show how this micro DApp application where it's can be put. So it may be the part of the ODU or it may be the part of the OCU, top of OCU or ODU. And then the which platform is going to control the micro app, DApp. So again, this is the area where standardization required, because again, it's not like that DApp or micro app is going to run continuously. If near real time RIC is going to manage, right, it can be scale up, scale down, or turn on, turn off. So if near real time RIC is able to do it, so that platform can be used. We can use the near real time RIC platform, and we are calling as a real time platform. Or if in few cases where platform should be the part of the ODU or part of the OCU, then it should the part of a top of at a ODU or OCU. But again, uh, when we are going to interact with the production environment or a multiple cell sites, then how we are going to move one application to the other cells, right? So that is again other standardization where we need to work on it. Can you go next slide, please? Yeah, again I want to show here open RAN network architecture. This aggregates the function within the GNodeB. So I want to show you how in OCU, micro app and DU can be part. So top of a protocol stack in a different pod, we can run the micro app and D app. And in later on, if we have the application which require a very less space, we can call as a nano app, right? That is after I think 3, 4, 5 years, then we have a new type of application which require a latency, very less latency. Can you go next slide, please? So here I'm going to talk about one application, and that is cloud gaming related application. So suppose as a user, I want to play a game, and that game require a latency less than 40 millisecond. And if I want to play that particular cloud gaming through a third-party server, like which is not part of the DU or which is not part of the operator's network, then latencies will be very high. And then for that, we require a Wi-Fi. It's very difficult to play that type of application in a mobility, or we are moving from A location to B location. So in that case, if operator can onboard that particular SDK at edge of the DU, means top of the DU, and from the DU side, we need to provide all those APIs which is going to support that particular cloud gaming application, like all the game logic. And that particular application can run top of the DU, mainly because DU can support the latency less than 40 milliseconds. I mean, DU or CU can also support. So, and in that case, standardization is required from DU side. All those APIs which enables that particular cloud gaming application, all the game logic. Only few APIs is available at the edge which can support, but not all.
So,
So
Nishant,
here
we are
other
approaching the.
area,
Hello?
it's not a network application, DApp or micro app. It's
Uh,
a new revenue generated application. So I want to give one example of the cloud gaming, but other example like a critical services, remote surgery. So all those type of applications should be the part of edge. And when there is a handover, means if a user is moving from A location to B location, in that condition CDN is going to play the role. It is going to shift that particular onboarded application to one edge to other edge based on the requirement of the latency and end user to fulfill the end user experience. Can you go to the next
I just
slide,
want to
please?
say we are approaching lunchtime.
Oh,
You want to
I'm
finish
not
up? Hello?
I'm not able to hear you. Can you please loud?
Can you hear me now?
Yeah.
Yeah.
Now I can hear you.
Okay. So we are approaching lunchtime here, and so if you want to finish in next 5 minutes or so, you can continue further. How many more slides you have for your first presentation?
Yeah. So this is the last slide. I have about three more slides. That's it.
But you have a second presentation. We can do that after lunch, right?
Yeah. Sir.
So let's finish it up in next 5 minutes, part one. And Jasprit, if you're still there, we have to check during lunchtime your audio problem and fix that so you can speak right after lunch and then
Can you hear me now?
you have echo. Let's do that during lunch. Okay.
Sure.
All right. Jasprit, can you mute
Can I
yourself?
continue?
Both of your instances. Thanks. All right. And Nishant, let's finish it up in next 5 minutes. We'll take the lunch break, then we'll come back. Okay.
Oh, yeah. Can you go to the next slide? Yeah. So again, MNO's challenges and standardization. So what MNOs is expecting from both vendor as well as a standardization. So one thing, uh, managing next generation network is increasing challenging because the complexity of 5G and then cloud infrastructure, then AI ML. So day by day, and then security also one of the major concern from the operator side. So that is one thing, means managing multiple things from the operator in, and then also they have to manage the legacy network. So here, when we are developing the standard, we have also make sure or keep in mind how we are going to manage the legacy network or old generation technology. Next slide, please. Yeah, so here my conclusion is if we want to develop any application, it should be the with the AIML available, and that application can benefit to the MNOs, or it can generate a parallel revenue part to the operators. Next slide, please. So future research standardization direction. So my recommendation is the same. When we are going to standardize, so it's not only related to the standardization of the network, it should also the cloud, AIML, security, so that everything's work together in a parallel. And then secondly, how we are going to look the legacy network where we are going to standardize a new technology. Because in security stuff, when we are going to standardize like TLS 1.2 or TLS 1.3, it is going to support previous generation TLS or not, right? So that is again my recommendation. So it's not only a standardization related to the feature technology, how it is going to support backward compatibility.
Mm. So, okay.
Yeah.
So
Thank
Nishant,
you. Yeah. So that is my last slide. Thank you, everyone, for your time.
can you hear me? Can you hear me, Nishant?
Yes, yeah, I can hear you. Yes.
Okay, so let's do one thing. So you gave us a presentation, and you have another we can take care of after lunch. What we wanted to hear from you is what exactly you would like to contribute to IEEE Open RAN industry connection, either through standardization, PAR, task force, specific area. We have things like configuration management is one area, right? I saw lots of operational aspects. I mean, if you think about a new area, so maybe you can talk about that after lunch when you speak on the second part of your talk. Because the whole idea of today's discussion is, well, we listened to the presentation, but it should be more as to what is gap, how exactly you're going to contribute to the task force within ORAN, right? So that's the real ask. But it's good to know your viewpoints and what's out there. You have done a careful analysis of some of the applicability as well, which is good. So your contribution could be in the form of a white paper, maybe create a new task force to generate some new ideas that could become a PAR, right? So we have a variety of things that can come out of today. Some of them, like Dilip's idea, was mature enough, so we took an action and go to PAR, right? The next item was also similar from Paul. The following one, we wanted to create a task force. So we need to have an action item for each presentation. That's why today's talks are a little different than yesterday's. So with that, I think here is 12:35 in Maryland. It's time for lunch, maybe time for dinner somewhere else. I would suggest we should come back around 1:10 p.m., about 35 minutes from now. And then Jasprit, once we take a lunch break, I'll talk to my colleague Sam to make sure things are fixed, and you can be the first speaker after lunch, okay? So 1:10 p.m. Eastern Standard Time, we'll be back. We're taking a lunch break, folks. And please join back. Thank you.
Thank you.
All right, so let's break out for lunch here, and we'll come back.